Day 732 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 525, contiguous array. The difficulty level is medium, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. Given a binary array nums, return the maximum length of a contiguous subarray with an equal number of 0 and 1s. All right, y'all, so that sounds simple enough, but let's go ahead and take a look at these examples just to make sure that we are doing this problem correctly. So, in example 1, we have our input nums equals an array of integers 0, 1. The output is 2. Explanation says 0, 1 is the longest contiguous subarray with an equal number of 0 and 1s. So, just to break this down one step further, this right here would be our subarray. Contiguous subarray means the numbers are right next to each other. So let's bring it down here. This would be a contiguous subarray, right? It's not an array where you can delete some, possibly none, just as long as you keep the same order. You can't delete any. They have to, the subarray, all of the elements in the subarray have to be already next to each other for it to be a contiguous subarray, right? We can't just go from here, delete this one and pick back up here. It doesn't work like that. It has to go from here to here, or from here to here, or here to here, whichever way you look at it, as long as the numbers are already next to each other and you don't delete any. So in this case, this would be our subarray. We have 1, 0, and we have 1, 1. This has a length of 2, so our output is 2. Now, just in case that didn't make sense, let's take a look at example 2. So in example 2, we have our input nums equals an array of integers 0, 1, 0. Our output is 2. Explanation says 0, 1 or 1, 0 is the longest contiguous subarray with an equal number of 0 and 1. So we can have this as a subarray, or we can have this as a subarray. This has 1, 0 and 1, 1, and this has 1, 0 and 1, 1 as well. They both have a length of 2, so the output is 2. Boom. Now, just in case that didn't make sense, let's take a look at example 3. So in example 3, we have our input nums equals an array of integers 0, 1, 1, 1, 1, 1, 0, 0, 0. The output is 6. So the explanation says this subarray right here, 1, 1, 0, 0, 0, is the longest contiguous subarray with an equal number of zeros and ones. So as you can see, this subarray right here has 3 1s, 3 zeros. It's the longest subarray that we can create with an equal number of 1s and zeros, and it has a length of 6. So that's why the output is 6, y'all. So I hope that makes sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution. Solution is not that difficult. Now, first thing we're going to do is we're going to create a dictionary to store the first index where a given count occurs. So the key is going to be the count and the value is going to be the index. So we're going to declare a variable called hash map, and we're going to set that equal to a dictionary. Key is integer, value is integer, and we could put the parentheses right outside like this. Boom. Then we're going to initialize with a count of 0 at index -1. This is going to handle cases where a valid subarray starts from index 0. So we'll just set hash map square bracket 0, set that equal to -1. Boom. Then we're going to count, declare a variable called count that tracks the difference between numbers of 1s and zeros. So it's going to be +1 for every 1 and negative or -1 for every 0. So we'll come underneath this, declare a variable called count, set that equal to 0. Boom. Then we're going to store the maximum length of the valid subarray found by declaring a variable called ans and set that equal to 0 as well. Now it's time to iterate through the array with the index and value. So we're going to say for, open up the parentheses I, comma num. Come outside of that, we're going to say in nums dot enumerated. This enumerated is going to get the index and the value at that index. Come outside of that, open up the brackets, and we're going to update the count. So it's going to be +1 if num equals 1 and -1 if num equals 0. So we're going to say count plus equals num equals 1. If that's true, open up, say question mark, we're going to say 1. If not true, colon, -1. Boom. Now, if this count has been seen before, it means that the subarray between the previous index and its current index has equal number of zeros and ones. So we come underneath this and we'll say if let prev index equals hash map square bracket count, come outside of that, open up the brackets, and we're going to calculate the length of this subarray and update the maximum answer. So we're going to say ands equals max, open up the parentheses, ands, comma, I minus prev index. Boom, come right here. Say else, we're going to open up the brackets. And if the count has not been seen before, we're going to store the current index as its first occurrence. So we're going to say hash map square bracket count, come outside of that, equals I. Boom. Then we're going to return the maximum length of the subarray with equal zeros and ones by coming down here. And we could just say return ands, y'all. Boom. That's all she wrote. Let's give it a run. Make sure it runs properly before we submit it. Let's see, it's accepted. So let's go ahead and submit it. Make sure it's still accepted after we submit it. And look at that, y'all. 7 milliseconds beats 98.78% of users. That's what I'm talking about. That's what I like to see, y'all. So, with that being said, y'all, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.